back to the morning show. It is now time to learn something new from someone new.
A fresh face is joining us for Wise Guys Wednesday. Nadia Mason, a familiar face, U of I physics professor, is here, but she has someone with her this morning. So Nadia, would you like to introduce this special guest?
Yes, I would. Today we have one of the newer members of our department, Jeff Filippini, and Jeff works on astrophysics, cosmology, and gravitation things. And so you guys have heard a lot about terrestrial things, and so we thought it was time to introduce some extraterrestrial interests. As you can see here. So, Jeff, take it away.
So tell us a little bit about your work.
So I work on problems where you try to connect the fundamental workings of the universe to stuff we see out in the universe. So the kind of science you might do at a particle accelerator, where you're trying to understand the fundamental workings of the cosmos, we look for evidence of that kind of thing out in space. So for example, I build telescopes that look at the afterglow of the Big Bang, that look at the earliest light from the universe, and from looking at that, we can sort of study how the universe was back then and thus understand how it got the way it is now.
Wow.
Interesting.
Good stuff. So what are we looking at?
Yeah.
So what are we looking at? So this is a picture of what I was talking about. So this is from a NASA experiment called WMAP, and this is a picture of what the sky would look like if you could see it at 150 gigahertz radiation. So light, the same kind of radiation used by your microwave oven. And so if you could look up at the sky, you wouldn't see the stars quite so much. You would see these little bright and dark, little hot and cold spots in the universe. So imagine you're inside this globe looking out. And those little hot and cold spots, this is actually the glow of the Big Bang itself. So the universe, we see the universe expanding today. If you run that movie backwards, the universe used to be denser and hotter than it is right now. And so that eventually it was as dense and hot as the surface of the sun. And so you see this glowing surface out there. And so this is actually, this is the glow of the Big Bang. This is the fact the universe really was hot and dense early on, and we see the evidence up in the sky today. This is a baby picture of our universe, and we can learn a lot from it.
Did you know that in school?
No, this is always all new information.
I did not know that.
Yeah, the Big Bang right here. And so I work on instruments that go to Antarctica, either from the ground or most recently from a balloon, that you observe. We try and do better measurements of this light, particularly the polarization of this light. That's another detail on that. But yeah, so by studying this baby picture, we can learn a lot about the physics of the early universe and the physics we've got today. That's one of the things I like about this kind of work, is that it's the same physics that goes on extraterrestrially out in the universe is what you see in your life today. It's the same rules govern the universe, and we can learn about them looking out there, the same things that we see here.
Okay. Oh, and is this picture, what is this?
Yes, so this is a picture of me on New Year's Day 2015, just before I came here as a faculty member, in front of the telescope I and a team of others built. This is called SPIDER. It's a balloon-borne instrument that hangs from a balloon at 120,000 feet, and this is just before we launched it in Antarctica. So this is sort of a poor man's satellite mission. You try and get above 99% of the atmosphere, so this is way higher, about 4 times higher than an airplane. And so from that altitude, you can sort of get the unobstructed view of a satellite at a little less cost.
And that was a couple years ago. Is that still up there?
No, it was up for about 2 weeks,
okay.
And we're currently analyzing the data frantically here and at other institutions. And we're currently working on, in my lab and in others, the pieces that'll go into a second flight of that telescope in about 1.5 years. So we're going to all go back to Antarctica.
Wow.
Yeah.
What are some of the exciting things that are happening in your field right now that kind of got you going? Because I don't know too much, but correct me if I'm wrong. But NASA had some findings recently. How does that kind of play into the work you do?
So there's a lot happening in cosmology right now. So the field I work on is called cosmology, so specifically looking at the structure and evolution of the universe. And so there's a lot happening with studies of the microwave background. There are massive surveys where you basically take a telescope and try and photograph where all the galaxies in the universe are. And by looking at their distribution, you can learn about how the universe works. And this is something that's been done here at NCSA, National Center for Supercomputing Applications. They work on the analysis of instruments like DES and soon LSST. So there's a huge amount going on with massive computer-driven telescopes and with sort of hand-built telescopes like my own.
Okay. Okay, and I have to know, is this something here?
Oh, yes. So one of the other things, so what this is essentially a large microchip. So this is a digital camera for millimeter wave radiation. For this, if you want to take a picture like this globe, you have to use a camera like this. And this uses this is using superconducting technology. It's the same kind of stuff developed in labs like Nadia Mason's. but we use it as a tool to observe the universe. So this whole thing cools down to a fraction of a degree above absolute zero, and we use it to take pictures of the sky.
All right, very
my
cool. Well,
goodness.
Jeff,
I
we're
need to go back
excited
to
to.
school.
I know,
need to
right?
do something with my life. What is going on?
We're excited to have you join us. If you have questions for Nadia, for Jeff, for Mats, you can send them to our Morning Show Facebook page. They'll be here every Wednesday. Excited to have you on board.
Thanks for having us.
We'll be right back with more of the Morning Show.